For the longest time, the whole AI world was obsessed with one thing: bigger models, more parameters, fancier architectures. But what if we've been looking in the wrong place? What if the real key to unlocking performance isn't the model at all? Today, we're flipping the script. We're talking about the data itself and how to engineer it with the kind of precision we usually reserve for production-grade software. And this is basically the dirty secret of applied AI. I've seen it 100 times. Teams will spend weeks, months, burning through insane amounts of compute trying to debug a model, when the real problem, the real villain, was hiding in their dataset the entire time. It's a painful cycle, but we're going to talk about how to break it. Look, if you're like me, building these huge distributed AI systems, you know this isn't some academic debate. This is a hardcore software engineering challenge. We need pipelines, we need validation, we need automation, because at scale, that old saying, garbage in, garbage out, gets a lot scarier. It becomes expensive, unpredictable, and frankly, dangerous garbage out. So that's the million-dollar question, right? How do we actually do this? It's not about just scraping more data anymore. It's about deliberately constructing a dataset with a purpose. So let's dive in and walk through the engineering discipline that gets you there. All right, so the very first thing we have to do is completely change how we think about data. We have to stop seeing datasets as these static, messy files we just throw in a bucket somewhere. It's time to start treating them like the critical pieces of software they are. We call this the data as code mindset.
I mean, think about it. You would never, ever push code to production without unit tests, right? Or without version control? No way. So why on earth would we treat our data, the very thing that dictates our model's entire brain, with any less discipline? This data as code idea is the bedrock for building AI that's actually reliable.
Okay, let's get into the nuts and bolts. Our first pillar is all about building an automated defense system for your data quality. And I'm not talking about some manual spot checking. I mean engineered, automated gates that live right inside your data pipeline. We're going to break this down into 3 super powerful, totally automatable checks. These are your first line of defense, and honestly, they'll save you from a world of hurt down the line. First up, schema validation. And I know, it sounds almost too basic, right? But trust me, this is mission critical. Before you do anything else, you define the exact shape your data has to have. The right keys, the right data types, no missing values, and you automatically reject anything that breaks the rules. This one step will prevent an insane amount of bugs. Okay, next up, deduplication. This is a classic one. If you have the same example in your dataset 10, 20, 100 times, the model just gets obsessed with that one pattern and completely forgets how to generalize. The fix is pure engineering. You programmatically hash every sample, creating a unique fingerprint, and just toss out any duplicates you find. It's clean, simple, and incredibly effective. All right, this next one is a little sneakier, but man, is it a killer for model performance. Imagine your data tells the model that I need to reset my password requires one action, but I can't log in requires a completely different one. You're teaching the model to be confused. So at scale, we use embeddings to find these semantically similar inputs and automatically flag them when they have conflicting labels. We're literally hunting for confusion and engineering it out of the dataset. Okay, pillar number 2. And this one is a big one because we're about to bust a huge myth in AI. The idea that more data is always the answer. That's old thinking. Fine-tuning is about precision, not just piling on terabytes of junk data. So, check out this table. This is basically a cheat sheet for how much high-quality data you actually need. Want to teach the model a new writing style? You probably only need a few hundred really good examples, not 100,000. Needed to learn your company's internal jargon? Maybe a couple thousand. It's about being strategic, which saves you a ton of time and money. And this leads us to a way smarter workflow. Instead of one giant training run, you start small. You train on, say, 500 pristine examples. Then you test the heck out of it, and you log every single place it fails. Then, and this is the key, you go back and add very specific data just to fix those failures. It's a loop. Train, test, find the weak spots, and then surgically add the data to fix them. It's precision engineering. All right, on to our final pillar, which is all about getting this pipeline ready for the real world, for production. This is where we take all those best practices from software development and apply them directly to our data lifecycle. Let's talk instructions. Look at the bad example. Answer the question. What does that even mean? It's totally useless, gives the model zero context. Now look at the good one. It defines the persona, the rules, the constraints. You have to train your data with instructions that are identical to how you'll use the model in production.
And it's the same thing for the outputs. We're not building a philosopher, We're building a tool that needs to be predictable. An output like "it depends" is a failure. What we need are deterministic, clear answers, like reject request due to missing approval ID. In a production system, consistency beats human-like rambling every single time.
Okay, listen up because this part is absolutely 100% non-negotiable for any serious AI team. You have to version your datasets just like you version your code. That means a version number, a changelog explaining what you fixed or added, and the evaluation scores for that version. If you don't do this, good luck debugging or rolling back a change. It's basically impossible.
And this isn't some high-level, abstract concept. We're talking about something as simple and clean as a good directory structure. This kind of organization is what lets you run experiments, track what works, and keep your whole development process from descending into chaos.
Data security. This cannot be a "we'll get to it later" kind of thing. It has to be step 0. You never ever just hope the model will ignore sensitive data. You engineer it out before a single training run. That means masking PII, hashing identifiers, replacing names, whatever it takes. This is a hard requirement, period. And here we are, the final gate. Think of this as your pre-flight check before you hit the big red train button and burn a ton of cash on compute. You take a small sample of your final dataset, run it through a base model, and just look at the outputs. Is it following instructions? Is the format right? If anything looks off, you go back and fix the data. This simple check can save you days of wasted time. So you do all this. You build the pipelines, you validate, you version, you do all this engineering work. What's the payoff? What do you get for all that effort? Well, it boils down to this one really powerful number. And there it is. That's the whole game right there. All that work means you get better performance with way less data, way less cost, and a system that's actually predictable. Quality doesn't just beat quantity here, it completely demolishes it.
So the message here is simple. Stop chasing bigger models and start engineering better data. The real question for you is, when you look at your own projects, what's that first piece of your pipeline you're going to tackle? Is it the schema validation, the versioning? That's where the journey to better AI really begins.